Hey, Algebra 2, welcome to part 2 of LFR7, Linear Systems Guided Notes. What we talked about yesterday is the three methods to solve, not yesterday, but whatever you watched the part 1 video. What we talked about is three methods to solve. We had graphing, elimination methods, and substitution methods. And what we're going to do today is we saw two that had solutions where they crossed, where the lines intersected. We've got two other cases though. We've got what happens, what does it look like in here when we do this when the lines are parallel, or when it's the same line. So let's go ahead and take a look at that business here. This we got here. We got x plus y equals 4, negative x minus y equals 6. What am I going to do for graphing? I tell you what I'm going to do. I'm going to do intercepts. I'm going to call this one line A and this one B. So for A, if I do my intercepts, if I say my x-intercept, if y is 0, if y is 0, I'd plug 0 in for y and x equals 4. And I'd also, for my y-intercept, I'd plug 0 in for x, and y would equal 4. So 0, 4. So this is, I've got 4, 0, and 0, 4. Oh, here we go. Sprayman's trying to make lines again. And close enough. No, that's not even close enough for me. We're going to roll with that one. Okay. And then for B, if we did intercepts, if I plugged 0 in for y to find my x-intercept, I'd have negative x equals 6, but I don't care about negative x, positive x. I'd divide both sides by negative 1 or multiply by negative 1, and x would equal 6. Could you have also solved these for y? Yeah, it's going to be the same thing. If I want my y-intercept when x is 0, I'd have negative y equals 6. We'd go through the same business. We'd have negative y equals 6, so y equals negative 6. Okay, so we've got this down here. I've got negative 6, 0, 0, negative 6. And in graphing, let's look here. I'm not the best line drawer, as you may know, but it looks to me like these are parallel. And you'll notice I said for graphing, it looks like. I'm doing the best I can. It just looks like it, though. Let's try elimination. Let's try elimination here. This is one of my favorites. That's why I chose this problem. X plus y equals 4, negative x minus y equals 6. Well, what if I added these together? Because if I just want, let me try to eliminate x, right? I've got a positive x and a negative x. If I added x plus negative x, I get 0. That would eliminate these things. I'm going to add these equations together. Well, x plus negative x is 0. Y plus negative y is 0. Interesting. And I get 4 plus 6 is 10. I get 0 equals 10. That doesn't give me a solution. I got rid of both the variables. And why is that? That's because since that's not a real solution. 0 does not equal 10. If you've never seen that before, that means does not equal. And since they don't equal, that's why this means no solution. Hey, I like that. Substitution is going to give us the same thing in a different way. X plus y equals 4, negative x minus y equals 6. Our step 1 for substitution is solve one of the variables. I'm sorry, try that again. Solve one of the equations for a variable. I'm going to take this first one and solve for x. I'm going to say x equals 4 minus y. So anywhere I see x, what am I going to put instead? Yes, person in the back. There's nobody here, actually. That's fine. I'm going to put in 4 minus y. So negative, because it's negative x, 4 minus y. Again, we're putting that in parentheses just in case. Minus y equals 6. Anywhere I saw x, the second one, that's where I put it. So distribute through. This is negative 4 plus y minus y equals 6. Well, that's weird again. I get negative 4. This is 0. Negative 4 equals 6. Negative 4 doesn't equal 6. And once again, because it's not equal and there's no variables here, we get no solution. And no solution, what does that mean? Parallel lines. Parallel lines. What does that look in the graph? Parallel lines, no solution. We got one more to take care of. Let's go ahead and look at the example, and I'm going to tell you ahead of time what we're doing, right? We're trying to get when they are the same line. What happens when they are the same line? It says x minus 3y equals, oh, we got to do some graphing, don't we? I'm going to do that one thing again. I'm going to do this method. This is called standard equation, standard form of a line. It's not a huge application, so there's a lot of weird rules that don't really matter a whole lot, so we don't push it. But what I'm going to do is once again, I'm going to call this line A and line B. I'm going to do intercepts because standard form works really well for intercepts. So for line A, we'll do the x-intercept again. So if y is 0, if I plug 0 in for y, I have x, well, this just gives me x equals 6. X equals 6. And then the other one, for the y-intercept, that would be when x is 0, and I'd have 0 minus 3y, or just negative 3y equals 6. Divide by negative 3, and y equals negative 2. So 0, negative 2 right there. So this is my line A graphed. Line B, let's see if I do this again here. Line B, so if I try to find my x-intercept, that's when y equals 0. So I'd have 4x, I'll write that over here, 4x equals 24. Divide both by 4 and x equals 6. Interesting. Well, we know it should be. We know it should be interesting. And then here for the y-intercept, that's when x is 0. That's when x is 0. And we just say negative 12y equals 24. Divide both by negative 12. And y equals negative 2. So if I plot the point 6, 0, which is already done, and then 0, negative 2, which I've already done. If I graph this line is also the same line. If they are the same line, how many times does a line touch itself if it's the same line? And the answer is it always. Always. What is always in mathematical terms? We call that infinite. So there's an infinite number of solutions. Infinite solutions. That whole sideways 8 that I just drew really poorly, that's infinite. Infinite solutions. How does that look in elimination? Well, let's find out here. I have x minus 3y equals 6, and I have 4x minus 12y equals 24. Well, I can't just straight eliminate one of these things right now, but this is kind of weird. What if I did this? Let's just say in this case, I'm going to get rid of x, right? What if I took this entire first equation? I'm going to kind of do this. What if I took this entire first equation and multiplied it by 4? If I did that, this would be 4x minus 12y equals 24. And the second would be 4x minus 12y equals 24. If I subtract these equations, I get 0 plus 0 equals 0. I get 0 equals 0, which is true. We get a true statement. And with a true statement, this is true, that means it's the same line. It means it's the same line. And once again, we still have, because it's the same problem, infinite solutions. What does substitution look like? Let's rewrite it. X minus 3y equals 6. 4x minus 12y equals 24. Solve one equation for one variable. I've got x by itself. I'm going to say x equals 3y plus 6 because I'm adding 3y to both sides. So I'm going to substitute wherever I see x in the second equation. Instead, I'm going to put 3y plus 6. So 4 times 3y plus 6 minus 12y equals 24. If I distribute through, I get 12y plus 24 minus 12y equals 24. That's where it gets fun. I collect like terms. 12y minus 12y is 0. And I get 24 equals 24. That's just another true statement. 24 does equal 24. So what that means this is true, and these are the same line with infinite solutions. Okay, you've seen the 3 methods 4 times. Okay, we've also kind of at this point got an idea of maybe when is one better to use than another. So that's what our last part, this is kind of this discussion. Oh, I forgot about this one. Use your method of choice to solve. We got this boat travels, I know it looks kind of weird, apologize for that. 18 kilometers per hour for its port, from its port. Second boat does all that good stuff. We got this system of equation. And what we're trying to find is how many hours will it take for the second boat to catch up for the first boat, and how far will the boats be from their port? In other words, we've got D for distance, so D is distance, and we've got T for time. So that's what we've got in here. We've got 2 of these things. D equals 18T plus 34, and D equals 22T. What am I going to use? I'm not going to graph. If I want exact solutions, I don't graph. If I want an approximate solution with a pretty good idea, I'll graph, right? If they're both in slope intercept form or point slope form, I'll graph. If they're in standard form, so it's easy or simple to get my intercepts to graph, I'll do that too. But in this case, I'm not going to graph. In fact, I would choose substitution or elimination. My personal favorite, I love substitution. The elegance of substitution makes so much sense to me. But maybe you don't like that. You're still going to have to show me at some point on the test. But maybe you like this here. Maybe you like elimination. Because if I subtracted these 2 equations, I have D minus D, which is 0. 18 minus 22T, negative 4T, not 40, negative 4T. 34 minus 0, so plus 34. I got one equation and one unknown. I can solve this. If I add 4T to both sides, I get 4T equals 34. If I divide both sides by 4, I get T equals 34 divided by 4. I know what you're saying. Mr. Brayman, you're going to have to use a decimal. In this case, it does make sense. 8.5. 8.5. T is 8.5. 8.5 what? T represents the amount of time in hours. So we got in 8.5 hours, 8.5 hours. They will be how far from port? Well, we got to plug it back in and figure out. It doesn't matter which one I plug it into, that's going to give me the same answer. I'm going to use the second one. It's shorter. D equals 22 times 8.5. D equals 22 times 8.5. And so what we got to do, what is 22 times 8? And it's really okay. You could totally use a calculator. And 22 times 8.5 in this case is 187. And again, we're going to say 187 what? What did D mean? Distance the boat in kilometers. So in 8.5 hours, they will be 187 kilometers from port. Now, it's not the best use of, it's not the best way to do word problems necessarily, but we're going to make it work. We're going to have that discussion too. So let's go ahead and finish this guy up. What is the most efficient method, or for when is it most efficient to use each method? And I will tell you, for graphing, I want to say graphing, it's for approximation. Oh my goodness. Approximation. Because especially if the answer is not a whole number, especially if the answer is not a whole number, it's going to be really tough to figure out exactly how it was. So only as good as your graph. And if you've seen my lines, which I think you have at this point, I'd be pretty bad at that. I practiced. If I had paper and was doing it something like that, I would definitely use a ruler. I would definitely use a ruler. But it's still, if I've got partials, fractions, I'm not going to be able to figure out the fractions. Great. Elimination and substitution. When do you use those? For me, it's personal preference. For these two, I need exact solutions. I'll just say exact and exact. And for elimination, for me, it's when it's easy to eliminate one variable. When easy to eliminate one variable. When you add or subtract or have to multiply first. But if you have to multiply first, in my opinion, then I would go to substitution. Because for substitution, I think it's most efficient when it's easy to solve for one variable, to plug in. And it's easy to solve for a variable. Those are my opinions on this. Now you will have to, on the test, you're gonna have to show me each way. Okay, and then find solutions if they do exist. You can check your work with the other ways, but you need to show me that answer. I might even have one problem. It's like, hey, show me all the ways. I don't know. Lots of things going on. Okay. With that said, I know that's a lot. We're going to take a little bit of time on this one, and that's okay. I hope you guys are doing well. Hope you guys are working hard, and I hope you guys are asking questions. I'm here to answer them. Show up to the live sessions, show up to the Zoom office hours, show up when you need me, email me. We can get this going. Okay. You guys take care. Have a great day, night, morning, whatever's going on in your life right now. Talk to you guys soon.